In this video I'm going to do one example of a differential equation where I just solve for the general solution. And I might want to note this is part 2. It's the second video in a series of videos that I've got on my channel pertaining to differential equations. Alright, I picked this particular example because it's got that y prime in there instead of the typical dy over dx, which you're kind of used to seeing. Alright, however, we can still do this the exact same way. At some point in time in my work I will replace that with a dy over dx just so that I can actually see that when I go to separate my variables. Alright, but initially I'm going to work it just like it is here. I think to separate my variables I like my x's on my right, my y's on my left. Even though that's got an x and a y in it, I still think I'm going to go ahead and add that to both sides of the equation. So then I'm going to have a 1 plus x squared y prime is equal to 2xy. Okay, from there, I think I'm going to divide both sides by that quantity of 1 plus x squared. Alright, so 1 plus x squared. That makes those two things cross out over there. When I divide this, I'll have a 1 plus x squared on that side. Alright, so I'm getting closer to having my variables separated. I'm going to have a y prime equals 2xy all over the quantity 1 plus x squared. Okay, I still have a y on that right hand side of the equation. Alright, so it's in the top, so I can divide both sides by y. Okay, when I divide it there, it's going to go away on that side, and when I divide this on this side, I'll have a divide by y over here. Alright, now I am going to clean this up here a little bit so that it's going to be easier when we get down to the integrating stage. There's a little imaginary 1 that's sitting right there, so I think I'm going to write this side as 1 over y prime is equal to a 2x over 1 plus x squared. Alright, now at this point, I think for me it's going to be easier if I have a dy over dx right there. Okay, this is first derivative, dy over dx is first derivative, so I can make that substitution. Alright, let's write that over here somewhere. Y prime is equal to dy over dx. Alright, so I'm just going to do that little substitution right there. Okay, so I'm going to have 1 over y, and then times dy over dx equals a 2x over 1 plus x squared. Okay, now that shows me I've got that dx on the left hand side and I need it on the right hand side. I'm going to multiply both sides by that dx. I'll even go ahead and show that algebra step right there. If I multiply this side by a dx, alright, then they're going to go away. And when I multiply this side by the dx, it's going to be over there. Okay, so let's clean that line up. I'm going to have a 1 over y dy equals a 2x over 1 plus x squared dx. Alright, after all of that, I finally now do have my variables separated. I've got my y's on my left, I've got my x's on the right. Okay, so at this point now, I can integrate both sides. Let's do that in red so it stands out a little bit. Alright, I'm going to integrate both sides. Alright, now, this left-hand side integrates very, very easily. Alright, this one, some of you may be able to do it in your head, some of you may not. If you actually need to show the integration on that, well, then do it somewhere on the side of your paper. Alright, I am going to walk through that here. Let's go ahead and integrate this side. This is going to be natural log absolute value of y on that left-hand side. Okay, and then I think I can squeeze it on over here. Let's actually integrate that over here. I'm going to have a 2x over 1 plus x squared dx. Alright, and if you need, it's a u substitution. Okay, so I'm going to let my u be a 1 plus x squared. Du is going to be a 2x dx. Alright, if I solve all the way down, du over 2x equals dx. Alright, so rewriting this here, I'm going to have the integral of 2x over u times du over 2x. Alright, x's are going to go away, or 2x, 2 and x, 2x is going to go away. Okay, so I'm going to be integrating 1 over u du. Alright, I integrate that with the natural log, absolute value of u plus c. Replace my u in there, natural log, absolute value, 1 plus x squared plus c. Okay, so like you can do that on another piece of paper or whatever, but I didn't want to leave that out. Okay, so let's go ahead and then put this on the right hand side because I integrated and I can put it on the right hand side. So I'll have the natural log, absolute value of 1 plus x squared plus c. Alright, now if you recall, at this point, you need to, you might need to visualize that. You can put your little e in there so that you remember I've got to go to exponential form at this point. So I'm going to go e raised to this exponent is equal to the absolute value of y. Okay, so I'll write that right here. I'm going to scoot over it a little bit. E raised to the natural log, absolute value 1 plus x squared plus c is equal to absolute value of y. Alright, and then let's spell out what we did there. Alright, we went to exponential form. Alright. Okay, from there, now I've got a base that's showing some addition up here. So using my laws of exponents, I can separate this. Alright, and at the same time I want to do that, I'm going to go ahead and move the absolute value of y on the left-hand side just because I like it on the left-hand side. So absolute value of y. Alright, separating this using my laws of exponents. That's going to give me an e raised to the natural log, absolute value 1 plus x squared. Alright, and then times an e to the c. Alright, laws of exponents. When multiplying like bases, you add those exponents. So I had addition up here, and I can break it back down. So again, I want to make sure that we're identifying what we're doing here. So that is laws of exponents. Okay, so that's where that came from. Alright, now, this right here is another constant. Alright, and I want to let k equal e to the c. Alright, because I've already got a c. I already have a c up here. Alright, and this whole e to the c, an e raised to another constant is going to give me another constant. So I'm going to let k equal e to the c. Alright, so I can do that replacing on that side. So, and I'm going to put it in front, clean it up a little bit here. I'm going to have absolute value of y equals k e raised to the natural log, absolute value 1 plus x squared. Okay, now let's go one step farther here. Remembering your rules for e and natural log, I've got an e raised to the natural log of the absolute value of 1 plus x squared. Alright, so e raised to the natural log, alright, it's just going to be whatever's in there. It's the absolute value of 1 plus x squared. Alright, well if I take x squared, any number I plug in, I square it, I add 1 to it, it's going to be positive, so I'm going to be able to drop the absolute value bars and get rid of that e raised to the natural log, all in the same step. So I can simplify this down to absolute value of y equals k times the quantity of 1 plus x squared. Okay, I need to solve for y. That's an absolute value, so I'm going to get rid of the absolute value bars and do a plus or minus. So then I've got y equals plus or minus k times the quantity 1 plus x squared. Okay, so all of that, and I am now finally down to my general solution. Okay, so like I said, these are building in difficulty level. Alright, anytime that you end up, when your integration ends up with a natural log, you're probably going to have this e in there. You're going to have to remember laws of exponents. You're going to replace this with a k. Lots of things to remember, but it's the same steps over and over and over. Okay, so just one more example of a differential equation. If you liked the video, go ahead and give me a like, and if you're liking my presentation style, then go ahead and subscribe to the channel. Thanks.